See, I'm just showing a 3D view of a line. Okay, we can in fact even uh, keep it parallel to VP. Okay, so this is the line which is parallel to VP. The gray colored surface that you are seeing here is actually VP, and the green colored surface that you are seeing below is actually HP. Okay, and of course it is making an inclination of 30 degree with HP. Okay, and then so the one that is below, the point that is below is actually A, and the point that is above is actually B. So then we said, okay, this is not the only configuration where the line makes an angle of 30 degree with the HP. Currently it is actually making 30 degree, but it is also parallel to VP. Okay, and we also said that when it is actually parallel to VP, you would be able to see its true length and true inclination. So here is the true length. Okay, I'll slightly move it so that you understand that where the line is. Okay, uh, so uh, okay, so you see this line. Okay, so this is the line of length 50 mm. It is actually making an angle of 30 degree, and in HP you are seeing it as a straight line that is parallel to the XY line. I have not shown the XY line here, but the zero axis here, okay, is actually in the XY uh, is actually the XY line. Okay, all right. Now we start giving the rotation to it, rotation to this line about an axis that is perpendicular to HP. So that we can just see that it is, that indeed this point B here moves along a circle, and the point B in the projection of the point B in VP would move in a straight line, and the projection of point we call that as the point, no, not as point B but point B1. Okay, so the projection of point B1 would move in a straight line, and the projection of point B1 would move in a circle. So let us just see this. So you see that that is indeed happening in terms of VP HP projections. B1 in HP is moving in a circle, and B1 in VP, or B1's projection in VP is moving in a straight line. Okay, and at the same time you can also see the spatial view as we rotate. Okay, so the line itself is rotating, so the point A is fixed. Okay, the line itself is rotating. So we understand very well what happens in the for vertical plane and what happens in the horizontal plane when we do the projections. So there are circles and straight lines. But what about the spatial view? So what is the path that the line itself actually traces as we rotate? Actually, this is very helpful. I know you may not want to know it, but it is. I mean, I find it really elegant and really helpful in imagination. The path that it actually traces is something you see for yourself. Uh, so actually, as in the projections, see in VP it is tracing a straight line, in HP it is tracing a circle, and if you look at the spatial view, the line itself is actually tracing a cone. Okay, the cone you can see here. Uh, okay, so this is the cone. So you see, so that is what actually happens. Okay, so this is actually the locus of the line in spatial case. Okay, and actually even though we said that the line B1 V is actually tracing a straight line, and B1 H is tracing a circle. Okay, so what you're seeing here, so there is this straight line, there is this circle. So the straight line and the circle are essentially the projections of the circular face of the cone. Okay, uh, you might very well like to have this visualization. uh, okay, uh, so that is it. So as I said, so whenever we say that there is an inclination of especially of a line with HP, uh, you know uh, you of course you start with I start you take a line and start in a configuration where the line is parallel to VP, and then you also recognize that you can also rotate it. And if you sort of get to know in a straightforward manner how much to rotate, well and good, you can rotate. But otherwise, just to make up that information, you just recognize what is the locus as you rotate. Okay, so this is the locus. And it might help to think in terms of cone, but otherwise you can also think in terms of the circle and the straight line. But I thought I would give all the different perspectives of it. Okay, all right. So with this I'll close this video. No, before I close, let me also show that okay, so far I was rotating the line about an axis perpendicular to HP. Okay, now similarly what I will do is okay, uh, um, okay, now so similarly what I have done is I have taken another line again of a length 50 mm. So the fixed point is actually uh, uh, point A. Okay, and now I rotate it about an axis perpendicular to VP. Okay, uh, uh, okay. So as I as I sort of rotate, you can see that here in this case it's maybe I will call that point as B2. Okay, B2 in VP is actually tracing a circle, and the B2 in HP is actually tracing a straight line that you can see very clearly, and the left side projections. Okay, uh, right, and the line itself is actually tracing a cone. Okay, so the cone is actually the locus of the line as it is rotated perpendicular to about an axis perpendicular to VP. Okay, and the circular face and the horizontal and the flat face, or the circular circle and the flat line that you are showing are actually the projections of the circular face of this cone. Okay, uh, so this cone or its projections that you are seeing here actually captures the fact that we have a line which would which actually makes an angle of 45 degree with VP. Okay, so far we have a red line. Okay, both this red line and blue line are actually having length 50 mm. Okay, they start from point A. However, one is actually making an angle of 30 degree with HP. I'll show both of them. Okay, uh, uh, okay, so here the both the cones are shown. Okay, and of course their projections are also shown here. Okay, so now the question is this red color line. Okay, sorry, the red line, you look at the spatial view, so that actually makes an angle of 30 degree with HP. Okay, and this blue line actually makes an angle of 45 degree with the VP. Now, but the thing is, we want a line no, which satisfies both the condition. It should have 30 degree with HP and 45 degree with VP. So that will happen when these two cones intersect. So you see, so this is the place where the two cones intersect. So this is the line. So what I will do is I'll bring the red line towards this to this intersection. Okay. uh, okay, so it is almost at the intersection. Okay, so now so in order to bring to this intersection, you know how much you have to rotate. I think I have rotated by an angle of minus 55 degree. That's what it is showing here. Similarly, the blue line also I will rotate uh, along this locus and bring it to the intersection of the two cones. Okay, so okay, so when I bring it to the intersection, you know, the two lines actually like become coincident. Okay, they're almost coincident. Okay, all right, and here, you know, so after I brought them to the intersection of the cones. uh, okay, here also you see that the red line and the blue lines have become coincident, and more importantly, these two lines have come to a position where this straight line actually, which is the red cone. Okay, the red cone and this blue circular arc, which is representing the blue cone, they intersect. Okay, so just as in the spatial view we are looking at the intersection of the two cones, so whatever intersection is happening in the HP and VP is also represents the intersection of cones uh, in the spatial view, and our lines. Okay, that is A B1 and A B2. Okay, are earlier we didn't know how much to rotate, so we just had the locus. Now we got to know where to how much to rotate, so we bring to that particular rotation, so that B1 path and B2 path, wherever they intersect, so we are bringing at that particular point both uh, uh, though we at that particular point. Okay, so we will give a new name to it. We will call it as B itself. So at that particular point we are bringing B. Similarly here also in HP, so at the intersection of this line and this, uh, we are taking B's HP projection, and here also the intersection of the circle and the line, we are taking VP projection of point B. Okay, so with this AB constructed like this, it is satisfying both the condition that it is inclined at 30 degree with HP and also 45 degree with VP. Okay, so with this actually I'm going to conclude this video. We will go further with the presentation. Okay, uh, uh,